Hello Math30-2, welcome back to permutations and combinations. This one's lesson 7, problem solving with permutations and combinations. So before we just looked at permutations, we looked at combinations, now we're combining them both together into permutations and combinations. So let's take a look at the first question here. First question says, how many arrangements of the word poppies can be made with each of the following conditions? So key word here that we're looking at is arrangements. So how many arrangements of the word poppies? As soon as we see that, we know we're most likely dealing with permutations. So the word poppies, we're going to first use the fundamental counting principle. We're going to use the fundamental counting principle for this one. So we have 1, 2, 3, 4, 5, 6, 7. There are 7 letters, so that's 7 arrangement, 7 factorial, and then we have the p 3 times divided by 3 factorial. And that will give you your answer for that one. Now we're going to take a look at the next one. It says if the arrangement begins with p. So we're saying the arrangement is going to begin with p. So once again, we still have our 7. But it must begin with a p. Now there's only one choice for that. As soon as that happens, we have so there's one choice for this, which is our p, and then we have 6, 5, 4, 3, 2, 1. So that's really just 6 factorial. Now if we look at these remaining digits, all that's left are 2 p's that can be repeated. So 6 factorial divided by 2 factorial. Okay? Now let's take a look at number C, or letter C. If the first 2 letters are p, so here we want the first 2 letters to be p. Okay? Well, p is the same thing. It doesn't matter if I have p here or p here. It's same order. If I switch this around, the same, it looks the same, it's the same. So that's just 1 there. Now, how many letters are left? We have 5 letters left. If we take away 2 p's, there are 1, 2, 3, 4, 5 letters left. So that's just going to be another 1, 2, 5, 4, 3, 2, 1, which is the same as 5 factorial. But now, is there anything repeated? No, because the 2 p's being repeated are at the very front. So it's just 5 factorial to solve for that one. The next one says if all the p's are to be together. So now it says all p's must be together. So we have p, 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 and the order of them doesn't matter because if I switch these 2 p's around, nothing happens if I switch those p's around, or even if I switch these 2 p's around, nothing will happen. Still p, p, p. So that's all equal to 1 letter. We're going to say that's 1 letter. Now we could start with those 3 p's, that could be the second letters, those 3 p's. We could have that as the last. So there's many ways. So now these 3 p's count as 1, and I have 1, 2, 3, 4 others. So that's just going to be 5 factorial, because I have those 3 p's and 4 others, which gives me 5 factorial for my arrangements. So now let's take a look at my very last question here, or my very last letter for this question. It says the first letter is p, and the next one is not a p. So my first letter is p, next one's not a p. So first one must be p. Only one option for that one. Next letter cannot be a p. So how many options do we have that are not p? I have an O, I, E, and S. So that's 4 more options, right? Now what is next? We have 2 being used, so we will have another 5 left over. So that's still 5 factorial, or 5, 4, 3, 2, 1. But only 1 p is being used there, no p's are being used here, and we still have 2 p's to be used there. So we still have to go divide this by 2 factorial. So it's really 4 multiplied by 5 factorial divided by 2 factorial. And if we simplify that, that would be the same as 2 multiplied by 5 factorial. So it's 2 factorial, it's just 2. Okay? That's great. So the next one here is a little bit more complicated. It says a class consists of 5 girls and 7 boys. A committee is to be made consisting of 2 girls and 3 boys. Determine the number of ways a teacher can choose the committee if there are no further restrictions. Okay, so there are no further restrictions. Order doesn't matter here, does it? It doesn't matter if you're a girl and you're chosen first or second. You're still chosen, you're chosen. So simple. We just go out of this one, we have, out of 5 girls, we are choosing 2. Okay? Out of 7 boys, we are choosing 3. And that's and. 7 boys, we choose 3. As soon as we say and, we multiply. So that's all we have to do. We plug in our calculator. We'll get our answer. Next one says, Johnny, the principal's son, has to be on the committee. So if Johnny, the principal's son, must be on the committee. So, since it's the principal's son, he's a boy. So that's 1, choose 1. So there's 1 boy gone. Now if we look at it, there's only 6 other boys to choose from. Okay? If 1 boy's gone, there's 6 other boys to choose from. And instead of choosing 3, we're choosing 2. So there's 6 boys, we are choosing 2. So 1 boy is Johnny, then all 6 boys, we have 2 others. And that means still, we need 2 girls out of the 5. So out of 5, we're choosing 2 girls. That's it. That one is done. The next one is a little bit more tricky. It says, the twins Peter and Paul cannot both be on the committee. So look at this. If we have Peter, we can't have Paul. So there's more than one scenario here. We could have Peter and not Paul. We could have Paul and not Peter. Or we could have neither Paul nor Peter. So those are my 3 scenarios. So let's try the first one with Peter and not Paul. So we're saying we're choosing Peter. Peter is on the committee. So there's 1. Now, how many other boys do we have to choose from? Well, there's 7 boys. And now if Peter's on the committee, we cannot have Paul. So 7 boys minus Peter is 6. And then minus Paul is another 5. So we're taking away 2. So then for the rest of the boys, it's 5, choose 2. And for the girls, it's also out of 5 girls, there's only 5 girls to choose from, we're choosing 2. And that would give us our counsel of 1, 2, 5. 2 and 2 is 5. Okay? So that's one choice. This is for Paul, or Peter, and not Paul. Now our next one would be Paul and not Peter. So same idea. We have Paul, right? So 1, choose 1. There, Paul's on. We're good. Okay? Now, we look at that. Paul's on. But, we have another problem. We can't have now Peter. So, without Paul and Peter, there's only 5 other boys to choose the next 2 from. And then we have 5 girls to choose 2 from as well. And now we're going to look at my last scenario. So, we have this scenario here, or this scenario here, or this scenario here. Okay? So my last scenario is, out of 5 boys, we're choosing 3, because that's no Paul or Peter, and, multiplying, and, out of 5 girls, we choose 2. That's it. We multiply that all together. And let's go look at this here. So Peter and 2 other boys, and, also I say and is multiply, and 2 other girls. Paul and 2 other boys, and 2 other girls. Then here we have 3 boys and 2 girls. Alright, next, last question. Okay, there we go. Last question is, so here's a situation. We have David, Stephen, Helen were trying to answer the following homework question. Okay, so here's the question. The students in a school band have practiced 5 popular 6 classical music compositions. Okay? For the school concert, they will choose a program consisting of 3 popular and 2 classical music compositions. And the order of composition matters, right? So the order of the compositions, the order of which they choose the songs matters here. Now determine the number of different programs in which can be presented. Alright, so here it says order matters. So we have 3 different students that are looking at this. We're going to discuss here which one's right, Dave, Helen, or Stephen, and which one's right and why. So first of all, David said 11 pick 5. That seems like a very logical thing. It says here that order of the composition matters. And we are picking 5 compositions, and there are 11 compositions. Seems good, but our problem with this one is what? There's 5 popular, and we can only have 3 popular, and there's 6 classical, and we can only have 2 classical. So that's the problem with his. So his makes sense, but there's a problem. Next one says, Stephen has, well, 5 permutation 3 and 6 permutation 2. Well, that makes sense, because out of 5 popular, we are choosing 3. And out of 6 classical, they're choosing 2, or they're picking 2. And order matters. So that makes a lot of sense. But also, like when we first pick them, does the order matter? The order doesn't really matter when you first pick them. Once they're picked, then order matters. So that's why this one's a bit odd. So then Helen says 5 combination 3 and 6 combination 2. Well, that makes sense because then you pick the first 3, you get your 3 compositions, you get your 2 or your 3 popular, you get your 2 classicals, and then you're good. Well, that makes sense. But then it also says order matters at the end. So those are the flaws in each one. Okay, so I'll let you guys fill that in, what those flaws are. But here now is the second one. Part B says the teachers determined that all 3 students are wrong. So determine the correct solution. Alright, so we're going to go back here. We want 5 popular, out of 5 popular we want 3. Okay? So out of 5 popular we're choosing 3. So first we're just seeing which ones they're going to use. Okay? And out of 6 classical, we are choosing 2. Okay? So that's what we have. Now that will give us our composition. That will give us which songs are being used. But now, after that, well, those songs, their order matters. So there's 2 ways of doing that. I could say 5, pick 5, because all those 5 songs, we're picking those 5 songs to be in a new order. Or I could have done this, which is correct, or I could have gone 5 factorial. Multiply by 5 factorial, which is essentially 5 pick 5 is 5 factorial. Because first, we have to choose our songs. Then once those songs are through, then we order them. And that's the way that is done. Okay? So good luck on the assignment. I'll see you tomorrow in class, and hopefully we get this done together. And see you tomorrow.